Identify alkanon X, gas Y, polymer P, compound Z, product F and G. Now we start with alkanon X. Now an alkanon X will undergo process C to give us propanate acid. So propanate acid is formed from oxidation of alcohols. So the process taking place here is oxidation. So it means this propanic acid is from an alcohol which forms propanic acid. So if the alkalic acid is having 3 carbon atoms, then the alcohol again will be having how many carbon atoms? 3 carbon atoms. So here this will be propanol. So alkanol X is propanol. Then we have concentrated sulfuric acid and filth. Now the process taking place there is dehydration. Removal of what? Water or elements of water. The elements of water are hydrogen and oxygen. So here we are having dehydration. We are having dehydration taking place there. So if this is propanol or propan-1-ol, then the process taking place here is dehydration. Then the gas formed here is an alkene. So this is propanol, and this one is going to be propene or prop-1E. So this one is propene. So we are trying to get what these ones are. So when you see concentrated sulfuric acid, what process is taking place? Dehydration. And in dehydration, if this is propanol, then the product is propene. If this is ethanol, then the product is eth. Are we together?
Yes.
Now, the next process, when you see high pressure, and this is an alkene, and this is polymer P. If this is propene, then the name of the polymer will start with poly, and then write the name of the monomer. The monomer is propene. So the polymer will be polypropene. So here this is polypropene. Polypropene. That is the polymer. Then we have our propene here. We have hydrogen, a catalyst, and high temperature. Then the compound Z. So if this is propene and we are adding hydrogen, then the product is going to be an alkane. So the process taking place here is hydrogenation. The process taking place is hydrogenation. And if it was propene, then it will become what? Propane. Are we together?
Yes.
Propene, then this one will become an alkane, so compound Z is propane. We have propane. You are heating in the presence of what? Excess oxygen. So when you see excess oxygen, then it means the combustion is complete combustion, whereby the whole of this propane is bound to two products, that is carbon dioxide and water. So if you decide that F is what? Carbon dioxide, then G is what? Water. If you decide that F is carbon dioxide, then G is what? Water. And what about if F is water, G is carbon dioxide? You can write the two interchangeably. Are we together?
Yes.
Very good. Maybe we can look at the chemistry behind it. We look at oxidation. We start with alkanon X, we form gas Y. How does this occur? So we start with propanol, which is like this. This is propan-1-ol. How many carbon atoms are you seeing? 1. Sorry. We start from this side. 1, 2, 3. Carbon number 1 is usually the carbon atom to which the hydroxyl group is attached. That is carbon number 1. Number 2, you now move away, counting like that. So this is propan-1-ol or propanol, because the hydroxyl group is attached to carbon number 1. Now, in the middle here, we have concentrated sulfuric 6 acid and heat. Now, during dehydration, what happens? When you see a single covalent bond like this, it means 2 electrons, one from carbon and another one from hydrogen. The same thing applies to this. When you see a single covalent bond, what do you know? 2 electrons. So, 1 electron will move from this carbon to the middle there. This other electron will move from that carbon to the middle there. Okay? And then after it has done like that, 1 electron will move in this direction and another electron will move in that direction. Okay? Now, when H combines with OH, what will happen? H2O. Are we together? Water will be formed. So the product formed here is H2O plus. Now, this one has already been removed. The whole of these have been removed. OH and H have been removed. Now, you write what is remaining, and then you make sure that you follow the rule, whereby each carbon atom is surrounded by how many covalent bonds? 4. 1, 2, 3, 4. So that is the rule. So you have what? 1, 2, 3, like that. And then you have that. Remember that we have removed H and OH. That's why you have not written anything there. So here we write what? H, 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 and this one H. What about here? When 1 electron was moved from this covalent bond to the middle here, and another electron was moved to the middle here, how many electrons are now in the middle here after adding these ones? They are now 2. So we'll be having the covalent bond which was there, which is this one. So this bond is this one, and then you include another one, which is another covalent bond, 2 electrons. So this is how you have formed the propene. So formation of propene, this is propene. Okay, that's how we have formed propene from what? Propanol. So that's the chemistry behind formation of propanol. Let us now see, we have formed propene. How do we form polymer P? Okay, we have formed propene. Now, for you to be able to draw propene, the polymer P, you do it like this. 1, 2. Double bond there, hydrogen here, hydrogen here. Now what do we mean? This hydrogen and this one are this and this. You have arranged like that so that you can easily do what? See. Then you come to this other carbon atom. We had a hydrogen up here, which is this hydrogen. But this one, you take it below. Are you seeing that? You take it below, that is here. So you write CH3. So what do you see? CH3 is this one. C is this one. H is H is this one is this one, and this one is this one. Are you seeing it? Are you seeing that? So that is propene. You put a bracket like this. You put a bracket like this. You write here N. Okay? Then you open the bracket. You show everything that is available. How many carbon atoms are in the straight chain? This straight one. 1, 2. Are we together? So we'll have 1, 2, and then H, and then H, and then CH3, and then H up there. You see where I've placed my H? And then you extend this one like this, and this one like that. Are you seeing that? Then you put a bracket like this, another bracket like that. Then you remember that N is there. So this is now propene. This is propene. And the product is what? Polypropene. The product is polypropene. So when you put into bracket N, this N actually refers to the number of monomers which are present in the polymer. Are we seeing? The number of monomers which are present where? In the polymer. So when you carry out polymerization, that is under what condition? High pressure. What do you form? Polymer P. And what is our polymer P? polypropene. Polypropene. Are you together up to that way? Polypropene. Another way that you can use to show it is like this. You can see you have a C, this is H, C3, double bond C, H, H. Plus another one like this. Are we together? So you have what? Plus C, H, double bond H, and then C, H, 3, and then H, like that. What do you do? How many carbons are in the straight chain now? 1, 2, 3, 4. Are you together? So you write what? You put a straight line and then you show how many carbon atoms? 4. 1, 2, 3, 4. You extend it like that. Are we together? Then what do you see on the top side? Hydrogen, 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 hydrogen. Everywhere is hydrogen. So you do exactly that. So you put a covalent bond, a covalent one, a covalent, like that. And then hydrogen, 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 hydrogen. Are we together up to that point? Now here is an alternation. C3, hydrogen. C3, hydrogen. So you do the same here. So here we have C3 and then hydrogen. CH3 and then hydrogen. So this is another polypropene. Propene. How many monomers of propene are you seeing? 1, 2. How many monomers are in the polymer? We'll count it from this way. So you have one which is from here this way, another one there. So in this case, don't put a bracket. Don't do what? Don't put a bracket and then N, because we will not have N here. Instead of N, how many monomers do you have? 2. So here N is equals to 2. In our case here, N is equals to 2. So here N is any number starting from 2 going on. Gas, gas Y. What is our gas Y? Propene, propene. So we have propene here, carbon like that, double bond like that, and you have hydrogen, hydrogen, here hydrogen, then here CH3. C3 is this one. C3. This group here. What are we adding? We are adding hydrogen. Hydrogen can be placed like that. Hydrogen, hydrogen, like that. Are we together? Then, what do we form? We look at the product which is going to be formed. Now, one hydrogen atom will come here, and another hydrogen atom will come where? Here. Using the flow of the atoms. The atoms are moving like that. So what will be formed? You'll have now 1, 2. Here we have CH3. Then here we have H. Here we have H. And here we have H. So you already have what was there. C3, H, H, H. C3, H, H, H. Are we together? Yes. Now, what is remaining now? 2 H's. The one which has come like that, and another one which has come. Are we together? So here we have hydrogen, and here we have what? Hydrogen. Look at that one very clearly. The rule is what? Each carbon to be surrounded by how many covalent bonds? 4. So let us open this one so that you can see the carbon atoms which are there. Sorry, the covalent bonds which are present. So for each carbon, we should be having how many covalent bonds? 4. So this carbon here we have 1, 2, 3, 4. Okay. This one 1, 2, 3, 4. This one 1, 2, 3, 4. So each carbon has been satisfied. This was propene. This was propene. We have carried out a process known as hydrogenation. So here, this is hydrogenation. Hydrogenation. Hydrogenation is a type of addition reaction. A type of what? Addition reaction. So hydrogenation of propene will lead to formation of propane. So the product is propane. Are we together? Propene undergoes hydrogenation to give us what? Propane. Propane. So we are done with compound Z. We have proved compound Z. Now we have propane. We have already add oxygen, excess oxygen in the form and heat. Now this is our propane. We can simplify this C and then H. How many C's do you see? 1, 2, 3. We are dealing with molecular formula. So C, 3. H. How many H? 1, 2, 3, 4, 5, 6, 7, 8. H, 8. Like that. This is a gas. We are reacting with what? Oxygen, which is a gas. Because oxygen was in excess, then it means there is complete combustion. There is what? Complete combustion. So during complete combustion, carbon dioxide and water is formed. Are we together?
Yes.
So the products formed from this equation are carbon dioxide, a gas, and water. Because there's too much heat from this equation from here, there's a lot of heat which is being produced. Then water also is in form of steam. It's in form of what? Steam. Therefore, it is in gaseous state. That's why you are writing gas, not liquid. Liquid. Let us balance the equation. Carbon 3. Carbon. What do you write here? Carbon 3. Are we together? Hydrogen 8. Hydrogen 2. How do you make this one 8? Multiply by 4. Very good. Oxygen. Let us start from the product side. 3 times 2, 6. R. 4 times 1, 4. So 3 times 2, which is 6 plus 4, 10. So how do you make this one 10? You multiply by 5. So right there 5. And this is the equation for the reaction. So this is the product F and G. Okay? Or what? G and F. You see how we have come up with the products?
Yes.
And remember, this is compound Z. Compound Z is what? Propane? Propane. Are we together?
Yes.
So with that one, we are done with the flow diagram for reactions between alcohols and hydrogen, oxidation of alcohols, okay? Oxidation of alcohols and what again? The first reaction here, alkanol X process C, which is oxidation, how do you form? Propanolic acid, okay? We can show this one again. Let us try that one. So we start from propanol, which is this one. This is H, 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 and then C, H, and then H, and then OH. Now, you carry out oxidation using a strong oxidizing agent, which can be what? Acidified. When you see H positive, it means what? Acidified. Acidified. It can be acidified potassium manganate 7 or acidified potassium dichromate 7. Like potassium dichromate 6. This is this two. Is it like that? KCr2O7. Or is it K2Cr27? This is the correct. Any of these. So potassium manganate 7 and potassium dichromate 6 are both strong oxidizing agents. So during oxidation, you usually show this hydrogen and you also show oxygen. Meaning, hydrogen is coming here and also oxygen is coming here. So what will happen? We have forgotten one thing here. There is another carbon here. So these carbons are how many? There are 3, like this. 1, 2, 3. To mean propanol, propan. So this OH will remain, but this one of these H will go out. Sorry, these two H will move out. You see the idea? So we'll have it like this. 1, 2, 3. Then here is not affected, so it will remain the way it is. This part has not been affected, that's why I've drawn it the way it is. This part again has not been affected, so you'll have H and then H. And then OH has not been affected, so it will remain the way it was. What is affected? This H and this H will combine with oxygen to give us what? Water. So what will be the product? Last H2O. Are you seeing that? H plus O. What do you get? H2O. And then these two bonds will come here together. This one and this one. The two covalent bonds have come in the middle there. Are we together? And then what is attached again? Oxygen. So this is now propanoic acid. So this was propanol. This was propanol. And this is propanoic acid. Propanoic acid. So when we meet in our next class, we will look at more flow diagrams, okay, and how we are going to do it, how we are supposed to follow the flow diagrams in answering questions.